What is up, high-value software engineers? We are going to continue the series where we're going to build a forever store, where we're going to basically store whatever we want in a decentralized peer-to-peer environment. So let's continue. Where did we start? Where did we left off, rather? Let me see. Let me do a git log. 2 episodes, which is Gucci. All right, so let me do make run. Okay, I think we started with this peer-to-peer package, right? We are implementing our own peer-to-peer package. Let me see. The main. Yes, and then I think TCP transport. All right, we have these things. So I think what we're going to do next is basically we are doing this message decoding here. And it's not the decoding of our payload, but it's the decoding of the RPC. Actually, the RPC between two peers. And I think what is this stamp actually? What the hell? I think remove the stamp, some relics, some leftover relics. And let me do settings real quick first. And make this 18 for the blind homies. I think what we're gonna do is open up message. And I think we're gonna rename this to RPC. An RPC struct. That makes more sense. RPC, and maybe we should rename the package to RPC, but hey. Message. So we're gonna say this is an RPC. We're gonna say RPC. This should be an RPC. And this is gonna be an RPC. And of course, this is going to be an RPC. RPC, all the things. What is going on here? This should be a small caps RPC, by the way. And let me open up. I think we're Gucci, actually. And I think we have some... The test is actually broken. Yeah, that's because we basically have our transport options, right? Instead of making this, so we should do like ops. It's going to be transport... TCP transport ops like this, and then we're going to say that the listen address is going to be let's do 3000 please. We need the handshake, right? We did our handshake func. That's going to be a knob handshake func. We're gonna, for now, we're not going to implement any handshake func. So you see that we have the ability to create a handshake func, but we don't gonna use it. And then we need a decoder. And of course we provided the default decoder. So we can just use that and then put in opts. What's going on here? Opts inside here, and then we wanna assert the listen address. That's gonna be the listen adder. Listen. Adder. Like this. And that's going to be... We could do something like this, right, to test it. Like this. Make test real quick. Undefined message encoding. Yeah, we need to change this. It's going to be an RPC. Do we actually want a pointer? Not quite sure. Not quite sure. Make test. I think we're blocking in a test, by the way. Yeah, the select statement. This should be good. Let's make test real quick. And everything is working fine. That's good. Then let's go to main. Let's do a make run. That's working. Let's open up telnet. My microphone is doing crazy stuff. Telnet's going to be localhost 3000. Now we're going to actually send some messages, by the way. We're going to say, hello, you. And then see what's going on. Yeah, so it's all working fine. We have from who is this coming? And the payload which is sending, which is fine. Working all good. let's open up transport real quick. The peer interface. I think the first method we're going to have in our peer is close. Very important. Close like this. So we can close the peer is connection. And if we open up TCP transport, or transport itself, enable to read these messages, we need to have some function which is called a consume, which will return a channel of RPC. And now we need to make sure that it's going to work. So we're going to say TCP transport. And that's going to be, let me quickly think about this. We're going to say an RPC chan, which is going to be a chan of RPC. A chan of RPC. And then we're going to say here that the RPC channel is going to be make me a chan of RPC. Easy. Then we need to implement our interface. We're going to say TCP transport. We're going to say consume. And that's going to return a channel of RPC. And you see this syntax, right? This basically means, if you watched the concurrency for beginners, this basically means we can only read from the channel and we cannot send to the channel, right? Very important. And we're just going to return the RPC channel like this. And then we could say consume implements the transport interface. Just like that. You could say which will return a read-only channel for reading the incoming messages received from another peer, actually. Received from another peer in the network. Yes, that's good. All right, so now we need to, let's get this cursor out of the way. Now we need to find a way to actually put that into our channel, right? So right now we're just printing this channel, but we're gonna say something like that the RPC channel is gonna be the RPC. It's gonna be an RPC. It's gonna be the RPC, right? What's going on? That's a pointer. We don't want that. Although we need the address here for decoding. So that's good. Yeah, this is failing because peer does not implement the close interface, right? The peer interface. So we're gonna say peer, TCP peer, by the way. We're gonna say close, gonna return an error, and we're just gonna say return p com close, and then we can say close implements the peer interface, just like that. All right, I think that's good. Let's test that out, right? How are we gonna do this? We're gonna say listen and accept. Maybe we're gonna boot up a new Go routine here quick to test this real fast. We're gonna say for tr consume. It's gonna be the message. I think it's something like that. Println message, or we could say printf. What's going on here? Printf, and then say percentage plus v. Maybe a new line, something like that. Is it gonna work? I have no clue. Let's run this. running is going, is working. We could say telnet localhost 3000 hello. Yeah, it's working fine, right? Although we have this relic, this /n relic for some reason. Yeah, we don't have a bad new line. It's crazy. Why is this wrong? Oh yeah, of course. This is not a new, this is a new line. I see. Make run. We could say telnet localhost 3000 and then do it again. Yes, perfectly fine. So now we can consume. It's very important because if we attach or transport to a server or something in some way, then we need to call consume on any kind of transport, and the TCP transport will return his channel. But for example, any other transport will also return his respective channel, which he communicates over the wire. And in our case, it's TCP, but it could be anything, right? We need to make it generic. So that's fine. It's actually capturing output. What's going on here? Let's close that. In my OBS. I hope it's fine. All right, so we have that. The next thing we're gonna do is we need to find a way, because let's open up real quick TCP transport. I'm gonna show you. Yeah. So this peer map, I don't think we're gonna keep it. We not need a peer map because I think the transport is not going to be responsible to keeping the peers, because peer is an interface. So we could. I think the server is responsible to maintaining a list of his peers, which could be a peer interface, which could be any peer, right? It could hold peers that are connected with TCP. It could hold peers that are connected with a local transport. It could even hold peers connected with gRPC. It does not really matter. A peer is an interface, and our server could hold any kind of peer, any kind of connection with his respective transport. That is the beauty of this generic implementation. But we need to have a function, we need to have a way to notify the server that there is a new peer, that the server can do with a new peer whatever he wants. So I think to do that is to do something in TCP, and we could say something, we have decoder, we have handshake func, we could say that the peer func or on peer is going to be a function of a peer with an error, right? And then we could say that if this function returns an error, we're going to drop the peer. How are we going to do this? First of all, I think I'm going to do something like this. I'm going to say a defer func here. I'm going to call it or not. How does it work? It's like this, right? And then we're going to say, actually, do it here. And then maybe say var error, error. Then yoink, paste it in here. And then we could say something like dropping peer connection. Read loop. Yeah. Dropping peer connection, and then we could say an error, which is going to be the error here on top. Then we're going to say con close. So we could not do anything here, we could just return here. This can be good. And here we could say if error. First of all, we're going to say if t on peer, right? If that's not nil, if somebody provided this function, then we're going to call it. If somebody does not provide this function, then we're not going to call it. But if somebody has provided us this function, then we're going to call it. Then we're going to say if r is t on peer, and we're going to say peer. No, it's going to be the peer, yeah, we just made. And if the error is not nil, then we're going to say these errors needs to be new errors actually. Then we're going to just return Something like that. So basically what happens is we're gonna do our handshake. If that's okay, then we're gonna do the on peer. If that fails, we're gonna drop. If that continues, then we're gonna start our read loop, right? Yeah, I think that's fine. So if you go to main, we could say here on peer. Let's try this without. Let's try this without first. Make run. So that should be normal, right? You could say telnet localhost 3000. Hello. You see everything is working fine. We get these messages. But if we say something like on peer, right? And we're going to say that's a function of peer error. And then we're going to say something like return fmt error f failed the on peer func. There should be a peer-to-peer peer, like this. And we run this again. Right? And then we connect in localhost 3000. Right? Wait, let me do this. Right? It instantly drops a connection. Right? So we connect it, and suddenly telnet just exits out. And that's because here, right, dropping peer connection failed the on peer func, which is nice because that means that our logic is working. And of course, we could say here, right, we could say let me do we could say on peer or something. We don't need to specify it in the directly into the transport options. Right, you could say on peer is going to be the on peer here. It's going to work perfectly fine as long as it has the correct signature, right? That's fine. Now we return an error, but we could also just return nil, right? So it's going to work. So we could return nil here, and then we could say fmt println, and we could say doing some logic with the peer outside of TCP transport. And let's boot telnet up, and then we could say hello. We can send messages, and then we're going to say doing some logic with the peer outside of transport. So it's all working fine. If we have a new peer, we are actually in a good spot. That's nice. All right, let's close it up. Yes, I think it's good. So, yeah. I think we're in a good spot. It's going to be a short episode, this one, because I think right now we have everything we need to have. Or maybe, wait, we can actually not. I want to test something. Because on peer, we could say this is the peer, right? And I want to test something. What happens if we do peer close? That's a good question. What happens if we do that? I'm gonna check it out. It's a very important thing because that's gonna basically drop the peer from whatever. Yeah. So we see that's good that we have this error. Now we have this loop, right? Use of closed network connection, and it's in the read. How are we going to fix this? Let's open up P real quick. Which is in transport, right? Close. It's in TCP transport, actually. It's here, right? If you have an error, we keep looping. Let me see. So what happens is that we have an error here in this decode. What are we gonna do? Are we gonna drop the connection? Or are we gonna check the error? Good question. Can we do net r closed? So I think we could do something like this, because I think if somebody sends us a wrong payload, I don't think we need to punish it. I don't think we need to punish him and say, yo, you're out because you sent a wrong payload. But of course, we could say something like this, right? R is going to be this. And then we could say if R is going to be net R closed, then we're going to say return. And we could do it like this. And otherwise, we're going to say it's a TCP read error. Is that something that's going to work? Let's try it out. Telnet localhost 3000. Use of closed network connection. It's not working. Oh, it's return. Yeah. I think it's fine. R closed. It is. R closed is return my IO is already been closed. Yeah, I think that's good, right? Because can we panic the R to see what kind of R this is? It's a very important thing we need to get working. It's not make run, it's going to be telnet, right? Yeah, you see, it's a use of closed network connection. The question is let us see. Reflect type of R. It's a net op error. That's can we not do this? Damn. Okay, I think we need to investigate this. I think enable to make this. Let's return. Let's return for now. Let's see. Let's just return. Right. And now it works, right? Now we have dropping a peer because we have a use of closed network connection. I think there should be a way so we can assert this specific error. So we only drop the peer if it's that error. Instead of just a normal error, actually. Another error. For example, a decode error or something, right? But hey, I think we need to figure it out soon. I will check it out, how we can do this. Maybe it's I don't know. We can see. We're gonna make it work. It's not a big of a deal for now. All right, so I think we're in a good spot to actually start implementing our storage and server and connect the dots. I think, although we will come back to this peer-to-peer to make this library a little bit better, to see what we are missing. And I think a good way to see what we are missing is to actually start implementing it so we can enhance this library. Because we're also, I'm planning to make the world's smallest blockchain, and I think we're going to use the same library, right? That would be nice. And of course, only for Patreons. Thanks for watching, and I'll see you in, I think, which is going to be episode 4. Thanks for supporting. Cheers.